Okay, so today we're going to take a look at 6-2, and we'll also go into 6-3 because they kind of state the same thing. So 6-2 is the first time we're going to introduce what a special type of quadrilateral is. The first one we're going to look at is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So here we have an example of a parallelogram in which the left and the right side would be parallel to each other. The top and the bottom of this quadrilateral would also be parallel. We have special names. Obviously, opposite sides do not share a vertex, so opposite sides are across from each other. Opposite angles also do not share a side. So opposite angles would be like if I mark this as A and this is A, like these are opposite from each other. And then B and B would be opposite from each other. We have what are known as consecutive angles. Consecutive angles are angles that are right next to each other. So we have this angle would be consecutive to this angle, but this angle would also be consecutive to this. So consecutive angles, consecutive means one after the other. So we have angles that are directly next to each other. And the reason that we're defining this terminology is that in parallelograms, these have special properties. So the first thing we have is that opposite sides in a parallelogram are congruent to each other. This should hopefully make sense because parallel means that you are the same distance from each other at all points along the line. So if you're measuring the shortest distance, so opposite sides of a parallelogram will be congruent to each other. So let's say that this was 7. Well, if this side is 7, this side would have to also be 7. And then let's say if this side is 9, then that side would also have to be 9. So consecutive angles are supplementary, which means that if this angle is, let's say, 30 degrees, then the angles that are directly next to this have to add up to 180 degrees. So if this is 30, this angle would have to be 150, but then this angle would also have to be 150 because it is consecutive with the same angle. So here's an example of using that. Obviously, if this angle is 54 degrees, the way to find out what x and y would be is you would just do 180 minus 54, and you get 126. So that means that both x and y would have to be 126 degrees because they have to add up to 180 with the angle that is 54. We also have that opposite angles are going to be congruent to each other. So angles that are across from each other are going to be the same. So in this example, B and D are across from each other. They are opposite, which means that they have to be the same. If we go back to the previous example that I just did, in which we were trying to find out what x and y were, we had this angle is 54, and then x and y were both 126. So even in this example where we were trying to figure out like angles that are consecutive, we still end up getting opposite angles are going to be congruent to each other. And we have the diagonals of a parallelogram bisect. So what that means is that bisect means it cuts into two congruent parts. So where they cross, you end up forming two congruent segments. So AE would be congruent to EC. So therefore, AE is the same measurement as EC, 7 and 7. We would also have that DE is going to be congruent to EB. And if I wanted to find out what x was, what I would do is I would say 2x plus 7 is equal to 16, because I know that DE is congruent to EB, and therefore they have to be equal. And then from there, I would just go ahead and solve this. So you would subtract 7 from both sides. You get 2x is going to be equal to 9 divided by 2, and you get x is 4.5, or 9/2. So here's a summary of kind of all the properties that we have in a parallelogram. Opposite sides are congruent. They are also parallel. You have consecutive angles are going to be supplementary, which means they add up to 180 degrees. Opposite angles are going to be congruent, so they're the same. And then diagonals bisect, which means that they cut each other into congruent segments. And here's the very last one, which is kind of just a continuation of what we've been looking at. So this says that if I have 3 parallel lines, L, M, and N, and if I know that AB is congruent to BC, then DE has to be congruent to EF. So that pretty much covers 6.2. I'm going to quickly go ahead and run through 6.3, because 6.3 is really just going reverse of 6.2. So 6.3 is saying proving that a quadrilateral is a parallelogram. So previously we had a parallelogram, in 6.3 we're going to try and prove that we have a parallelogram. So the very first way that you can prove that you have a parallelogram is that if both pairs of opposite sides are congruent, then it has to be a parallelogram. So if you have like BC and AD are the same, and AB and CD are the same, then that's a parallelogram. And you have to have both pairs, you can't just have one. So if I wanted to find the values to prove that this is a parallelogram, what I have to do is I need to find out what value of y would make y plus 3 equal to 2y minus 1, and then what value of x would give us 3x plus 5 is equal to 4x. So to have a parallelogram, both of those have to be true. So then from there we would just go ahead and solve. So I'm going to go ahead and move this y over here. So we subtract y from both sides. You get 3 is equal to y minus 1. Add 1. You get 4 is equal to y. Here, I'll subtract 3x over, and you get 5 is equal to x. So if y is 4 and x would be 5, then this shape would be a parallelogram, because I have shown that both opposite sides are congruent to each other in that case. If angles of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So if I have, in this case, let's say that angle A is 30 degrees, and then you know that both B and D are 150 degrees, then this would have to be a parallelogram. Part of this is because all the angles of a parallelogram have to add up to 360 degrees. Well, if you have 150 plus 150, you have 300. Then you add 30 to that, you get 330. The only thing left would be 30 degrees, and therefore that forces the angles. So if one angle is supplementary to both of its consecutive angles, if I only had A and B and I didn't know D, that would not be enough. You need one angle and both of its consecutive angles being being supplementary. So for what value of y must L, M, and P be a parallelogram? So here I have L and N are both 78. So for this to be a parallelogram, P has to be supplementary with both L and N. Luckily enough, L and N are congruent to each other. So that means that I would need to take 180 minus 78 that would give me 102 degrees. So if y was 102 degrees, then you would have a parallelogram. Another way that we can prove is that if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So hopefully now we're seeing a lot of like what we covered in 6.2 is just showing back up. So here we have an example where we want to determine if this is a parallelogram. I have this angle is congruent to that angle. Well, if we flip back to what we just looked at, it says both pairs of opposite angles have to be congruent. I only have two pairs, so this would be no. You need both pairs congruent. So I only have one pair. I would need to know that the other pair is also congruent to actually have a parallelogram. And then if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. This was the last property that we had for parallelograms. So if you have, and here I have one of my diagonals is bisected, I need to find out what value of x would make this a parallelogram. So that means that 6x needs to be equal to 7x minus 2. Then I'm just going to solve this. So you would subtract, I could subtract 7x from both sides. I get negative x is equal to negative 2, which then when you divide by or multiply by a negative 1 to get rid of the negatives, you find x is 2. So if my x value is 2, then this would be 12, because it's just 6 times 2. Over here you would have 7 times 2, which is 14, minus 2, which also gives you 12. So in that case, both of those would be congruent to each other, which means that BD is bisecting AC. BD cuts AC into two congruent segments. And then if one pair of opposite sides of a quadrilateral is both congruent and parallel, it would be a parallelogram. So the reason that this works is that if you're parallel, then you are the same distance from each other as from the shortest distance, if we think about this. So if this is parallel, then that means that BA and CD have to be congruent, as long as you also have that, BC and AD are congruent to each other. So if your segments are both parallel and congruent, then you have a parallelogram. So here's an example in which we have pretty much that property. The arrows say you are parallel. The dashes say that you are congruent. So yes, this would be a parallelogram. So in a summary, these are the properties that you can use to prove that you have a parallelogram. If you have both pairs of opposite sides are congruent, you're good. If you have both pairs of opposite angles congruent, you can prove that it is a parallelogram. If one angle is supplementary to both of its consecutive angles, it's very important that it has to be both. It cannot just be one. If the diagonals bisect each other, you have a parallelogram, and then if one pair of opposite sides are congruent and also parallel. So that covers the stuff in 6.3. There should be 2 math excels, one on 6.2 and one on 6.3.